Our remote learning experience. This lecture is for Monday, March 23rd. Okay, so this is our first official full week of going into remote learning. All right, so just a reminder, any missing assignments that you have, so that would be your conservation of mass lab, your double displacement lab, and single displacement labs. Those are all due tonight at 11:59 p.m. If you have not gotten them into me, please get them into me as soon as possible. Grading has been a little bit difficult around here, so the sooner that you get them in, the sooner I can get them into PowerSchool for you. Also, what was I going to say? Oh, yes, also your assessment is due tonight at 11:59 p.m. All right, so that needs to be either emailed to me or handed in through Microsoft Teams, and I'm going to go over Microsoft Teams a little bit later as well. All right, so we are actually transitioning to a new unit on the mole, okay? So I told you guys this was coming, and it's very exciting. This is going to be one of my favorite units. I think it's really fun. You might hate me for it, but you'll learn to love it, okay? So when we get to the mole, eventually we're going to be getting into some more like dimensional analysis stuff. So if you guys remember that from the beginning of the year, we are learning about how to convert from one unit to another. For example, going from grams to kilograms or liters to milliliters, things like that. That skill is going to be particularly useful for this unit. So if you are still shaky on dimensional analysis, if you need some practice problems, I can certainly give those to you, but that might be a skill that you would want to brush up on very soon on your own, okay? So we are going to be talking about the mole today, what it is, and why we use it. So even though I have a picture of a cute-ish mole right here, unfortunately, that is not what we're going to talk about today, so if that's why you came here, sorry to disappoint you. Although, you have to admit, this mole has very nice fingernails, but I don't know. Anyways, so the outcomes of our units. This is everyone's favorite term, SWABAT, which means students will be able to. So thus far, what you guys are going to be able to do is identify the difference between formula mass and molar mass, which we will learn more about today. You're going to be able to convert between moles, grams, and particles for any atom, molecule, or compound. You will also be able to describe the value of the mole for understanding chemical reactions, okay? So the mole is a very important unit that chemists use to kind of visualize very, very, very tiny atomic interactions. So you guys will figure out why we use the mole pretty soon. So those are our objectives, or our SWABAT. All right, not SWAMBAT, SWABAT. Okay, so why do we use the mole in the first place? This is an article that you guys are going to need to read. I'm going to link this article along with the assignment for this class. Actually, there won't really be an assignment for this class, but I do want you to read this article. It's from the American Chemical Society, and it's actually really straightforward. Let me take a quick look at it. See, like, how can you not read that? Look at this thing. All right, so this explains the mole, and it's very easy to read. Not saying that you guys aren't capable of difficult reading, but sometimes the mole is difficult to understand, and so this is super helpful. I really enjoyed reading this article, so I think that you will too. All right, back to it. How do we get this in full screen again? Oh, I didn't mean to do that. Slideshow. Current slide. Perfect. All right. So I am going to ask you to read that article once this is over if whatever I say does not clarify. Again, really cute picture of a mole. Also kind of inaccurate because they don't really have eyes. They're kind of blind. So if you ever see a mole like this, it's wrong. All right. Anyways, so why do we use the mole? So the mole is a unit, okay? It's like any other unit you can think of, all right? So say you have a dozen. A dozen means 12. So if you have a dozen eggs, you have 12 eggs. If you have a dozen pairs of shoes, you have 12 pairs of shoes. Yeah, things like that. So It is just another unit that helps us to visualize very, very, very tiny interactions, okay? So if you think about chemical reactions, they are interacting with each other at the atomic level. And chemists usually or really can't see those interactions. So the mole helps us to kind of visualize and understand those reactions a little bit better. Okay? So first I want to orient you to your periodic table. Okay, this isn't the exact one that I gave you, but this is one, it is still an accurate periodic table. And I want you guys to look right here to the relative atomic mass or just the atomic mass. Okay? So the atomic mass, which is all of these numbers underneath here, tells us kind of what the mass of one atom is. Okay, so this tells us that one atom of hydrogen weighs or is 1.01. Okay, 1.01 what? Usually measured in atomic mass units or AMU right here. So that means that every hydrogen atom on average weighs 1.01 AMUs. Okay, so remember that is an average that we've learned how to calculate before. Let me see if I can write on this very quickly. Aha. Okay, so think of this as measured in AMU. Okay, I would encourage you to take notes while I am speaking here. Okay, this is only going to be helpful for you guys. Yeah, so please take notes. All right, back to the presentation. All right, slideshow from current slide. Okay. So yes, we tend to measure this in atomic mass units, okay? But the issue with that is an atomic mass unit is very, very, very tiny, okay? So as you can see right here, one atomic mass unit is equal to 1.66 times 10 to the negative 24th grams, okay? So imagine like 23 zeros or 24 zeros in front of that 1.166. That is a lot of zeros, and that is very, 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 very tiny, okay? Too tiny for us to be able to measure, okay? But if we're a chemist and we want to do a chemical reaction, we're gonna need to be able to measure certain quantities, okay? But I can't rely on using that unit, AMU, because it is just way too small, okay? But the mole is used to help us kind of make that unit a little more macroscopic so that we can use it more when we study chemical reactions, okay? So the purpose of the mole is to count objects that we can't necessarily see. It's an indirect way of counting objects, but it's important too, okay? So it helps us to count atoms and molecules. And 1 mole of any substance represents 6.022 times 10 to the 23rd particles. So please write that down somewhere immediately right now. Put the stars next to it, put whatever you have to next to it, because this is a very important number, all right? This is called Avogadro's number. No, not avocado's number, Avogadro's number, okay? This is a very important number. So just like 1 dozen eggs equals 12 eggs, 1 mole equals 6.022 times 10 to the 23rd particles, okay? So let's say I have 1 mole of eggs. That means I have 6.022 times 10 to the 23rd eggs, which is way too many eggs if you actually think about it. But that is what that unit represents, okay? And so this allows us to kind of better understand different chemical reactions because it's obviously a much larger number, okay? So when I say that I have 1 mole of hydrogen, it means that I have 6.022 times 10 to the 23rd atoms of hydrogen, okay? So that's a lot of hydrogen atoms, all right?